Hello everyone, welcome to PUC Physics Explained channel. In this one, fourth session of the PUC first year physics chapter 1 units and measurements. In that I am going to take the continuation of significant figures. In the significant figures, the what we are going to consider for the measurement, and there the some arithmetic operations and measured values what we are going to have, those will have the some errors, and that errors in measurement I'm going to take in this session. And the errors what will occur in the measurement, those are also called as a uncertainty. Then how the uncertainty occurs, here we'll take an object of the measurement of the length by using the scale, and in that scale by the observation we'll have the different values. You can see, if you see the observe with the parallel to that object, we are going to have the 6.2 centimeter length, and if the somewhat other side if you observe, we are going to have the 6 centimeter distance. If you observe from the other side, from that measurement, we are going to have the 6.5 centimeter, and this is a error occurs due to observation, and that is also called a parallax error. And like this there are different error occurs, and those different types of the errors we are going to discuss here, the expression of the error, and and consideration of that in the different arithmetic operations, how the error occurs, those also we'll discuss. The errors in measurement refer to difference between the measured value of a quantity to its true or actual value. The difference between the true or actual value what the that quantity is having and the measured value of that quantity, the difference what it is there, it is called as a errors in measurement. These errors are inherent. Okay, those are always present in any measurement process. Those will always present in any measurement process due to various factors. And the understanding of them, the errors, is crucial for accurate scientific work. For this accurate scientific work, we should understand that what are the types of error occurs and how those occurs. Types of errors, that first one, systematic errors. These errors tend to be in one direction, either always positive or negative, and have a identifiable causes. And here the systematic errors what occurs, those may be in one direction, either positive or a negative side, and have the identifiable causes also. And they can be further categorized as instrumental errors, arising from imperfections in the measuring instrument or its calibration. Okay, the any measuring instrument we are going to use for the measurement, if they have some imperfections or its calibration means the comparison with the standard, during that it may have some imperfection, then that type of error we are going to call as a instrumental error. Example we'll take, that is a faulty thermometer. The thermometer which is used for the measurement of the temperature, if the thermometer is having some fault in it, it may not give the actual temperature what is to be measured. And that temperature measured by that faulty thermometer is called as a instrumental error. Like that, the all the measuring instrument, if you have the imperfections or during its calibration, then those will give the some errors. Those are the instrumental errors. Next, observational errors. Due to limitations or mistakes in the observer's technique, the how the observers will look the reading. By that, the what the error will occur. That is called as a limitations or mistake of the observer's techniques. The parallax error is an example of that one. In the first slide, what I've discussed the measurement of the length by using the scale, and there the error what are occurred Those are called as parallax errors. Then next one, environmental errors caused by external factors like temperature, pressure, and magnetic fields. The sum of the objects, some of the magnitudes will affect by these external factors. If the temperature changes, the some parameters will change, like the length of the metals, like the volume of the gas, like that. And here, these what are the factors are there. Due to that, the change in the readings are errors. What occurs? Those are called as environmental errors, which are caused by the measuring environment. Then next, experimental technique errors resulting from improper experimental procedures. For the measurement, the some experimental procedure are to be followed. If the experimental procedure is not proper, the some errors may occur, and those errors are called as experimental technique errors. Then these are the systematic errors which will occur during the measurement. The next type of errors are the random errors. These errors occurs unpredictably and have the no specific pattern also, and their cause is often unknown. The cause is also unknown, and they may be positive or negative, and that's why the random errors occurs randomly. Okay, those are not predictable and not having the specific pattern also, and those are unknown. Their cause is also unknown, and these are the random errors. The next type of errors are called as the least count error. The every instrument which is used for the measurement having the some least count. The least count is the smallest value that can be measured by that instrument. The smallest value. If you take the length measuring instrument, the smallest length what can be measured by that instrument, that is called as the least count of that instrument. Example, if you take the vernier caliper or micrometer screw gauge, which will usually commonly have the least count of 0.001 mm or zero point zero 0.01 mm, like that. And due to that, the smallest value that can be measured, due to that least count, what the error occurs, that is called as a least count error. These are the different types of the errors which will occur during the measurement. Then moving further, the expressing the errors. These errors, how those can be expressed? Okay, the first one, expression in the form of absolute error. Then this absolute error is the magnitude. Magnitude of the difference between the measured value and the true value. The measured value is from the measurement of from the instrument what the value we are going to get, and true value is the actual value of that uh, object is there, and difference between these two what is there, that is the absolute error. This can be given as absolute error equal to value measured to the value actual, the difference, and this is taken as the mod. Therefore, the always we are going to get the positive result. Then second one is the relative error. The relative error is the ratio of the absolute error to the true or actual value. The absolute error what we have taken here to the actual value ratio if you take, that is the relative error. The absolute error to the actual value is the relative error, that is the Vm minus Va by Va. Measured value to the minus of the actual value to the actual value. This is the absolute error. The third one expression is the percentage error. The relative error, what we have calculated here, if that is expressed in terms of the percentage, that is called as a percentage error. Then that is given as this relative error. There is a value measured minus of the value actual to the value actual multiplied with 100. That is the percentage error. Then moving further, example if you take for the calculation of all these errors, if the true length of an object is 10.0 centimeter and a measurement yields the measured value is the 9.8 centimeter. Then all these three of the errors how we can get? The absolute error is the measured value minus of the actual value, that is 9.8 minus of 10.0 is 0.2 centimeter. Mod we have taken, that's why it will be positive. Then relative error, the absolute error by actual or true value 10.0, it is 0.2 by 10.0, it is 0.002, 0.02. That is the relative error. Then percentage error, it is the expression of the relative error in terms of the percentage is percentage error. That how we can express? If you multiply with 100, we are going to get in terms of the percentage, that is 0.02 multiplied with 100, it is a 2%. Then here the some rules of determining the uncertainty in the results of arithmetic calculations that we have to discuss as a syllabus of the in this first year physics chapter, the units and measurements. The uncertainty is the error. Okay, the how we will take that is what are the rules. To take that rules, we are going to take the some examples. Then what is this mean by uncertainty? The rules for the determining the uncertainty or error in the number or measured quantity in arithmetic operations can be understood from the following examples. First one, if the length and breadth of thin rectangular sheet are measured using meter scale. Okay, length and breadth of the thin rectangular sheet is measured using the meter scale. That is given as 16.2 centimeter and 10.1 centimeter. Length is 16.2 centimeter and breadth is 10.1 centimeter respectively. There are three significant figures in each of measurement. In both the cases, there are three significant figures. We can see it means that the length L may be written as the length how we can write length L equal to 16.2 plus or minus 0.1 centimeter. The 0.1 centimeter is the absolute error that can occur in the measurement of the length. Then this can be given as 16.2 plus or minus 0.6%. The relative error what is there 0.1 centimeter, that if you take in terms of the percentage it is a 0.6%. That is 0.1 by 16.2 into 100, that is in terms of the 6%, 0.6%, that is taken here. Then here the actual length may be 16.2 plus 0.1 or 16.2 minus 0.1. Okay, that may be the length and that is expressed in terms of the errors like this. Similarly, the breadth may be written as B equal to 10.1 plus or minus 0.1 relative error, absolute error. Then here that can be written as 10.1 plus or minus 1%. A percentage error how we can take, that is a absolute error by actual value, there is a relative error multiplied with 100, the percentage error we can say. Then the error of the product of two or more experimental values. If you take the product of two or more experimental values using combination of errors rule will be here the product we are going to take the length and the breadth, and from that only the combination of errors rule we can discuss. The ln to b can be given as 16.2 multiplied with a 10.1, that will give the 163.62 centimeter square, plus the error here the combination of errors is taken. How the combination errors can be taken? In the length 1% error is there in the length, and in the breadth it is 0.6% error, both are added, then it is 1.6%. Then 1.6 percentage, how much value it will have? Okay, then 1.6% of this value we will take, that is 1.6 163.62 into 1.6 by 100, that is equal to 2.6, and that 2.6 value of the area can be added, and this further how we can simplify. This leads us to quote final result as L into B, that is 164 plus of 3 centimeter square. How this 164 comes? The rounding off of the values. Here 163.62. This zero point 0.6 what is there, it is more than 5. Therefore, this 3 is increased by 1 digit. Therefore, this becomes a 164. And this 2.6, the zero point 0.6 is having more than 0.5. Therefore, this is increased by 1. Then this becomes a 3 centimeter square. Then here 3 centimeter square is the uncertainty or error in the estimation of area of rectangular sheet. In the estimation of the area of the rectangular sheet, the 3% of the uncertainty or error can occur. Then further moving in the second, that what will take the consideration of the uncertainty measurement. If a set of experimental data, if number of experimental data having in a set, for example, if you take the 10 experimental data if you have, then those are specified in n significant figures. These all data are specified in n significant figures. Then the result obtained combining these data, the result, final result, what we are going to obtain by the combining these data of the experiments will also valid to n significant figures. The result will be having the n significant figures only. Okay, that is the rule what we can have. Then, however, if the data are subtracted, okay, that the simplifying of that result, if the data are subtracted, then the number of significant figures can be reduced by the rule of the subtraction. Okay, the significant figure consideration in the subtraction that will be applied. For example, 12.9 gram mass minus of 7.06 gram mass, both specified to three significant figures. These are having the three significant figures. Cannot properly evaluated as 5.84 gram. Okay, this result will give the 5.84 gram, but only as 5.8 gram because of the subtraction rules. In the addition and subtraction, the decimal value in the result will be the minimum decimal value in any of the number which is used in the calculation. Here this one is having the minimum decimal value 1. Then the result should have the 1 decimal value only. Okay, then this value as the result we are going to have from the subtraction rules. Then as uncertainties in subtraction or addition combine in different fashion. Okay, here the uncertainties what are there? This is addition and subtraction combined in a different fashion. And that what is the rule is there? Smallest number of decimal places rather than the number of significant figures in any of the numbers added or subtracted. Okay, here the not we are going to consider the number of significant figures in the numbers, but we are going to consider the least decimal place in the any of the number which is used in the addition or subtraction, that we are going to use here. Further moving, third one, the relative error. The relative error, which is the ratio of the absolute error to the actual value, and of a value of a number specified. Two significant figures depend not only on n. Okay, how many significant figures are there in the numbers which are taken in the arithmetic operation? On that it will not depend, but also depend on the number itself, because relative error will have the original or a true value. Based on that, the relative error will be depend. Already we have discussed. The further we will take an example here. The accuracy in measurement of mass 1.02 gram is plus or minus 0.01, that is absolute error. The another measurement 9.81 gram is also accurate to plus or minus 0.01 absolute error. The relative error in 1.02 is absolute error by the true value, that is absolute error 0.01 by true value 1.02 is relative error. If it is expressed in percentage into 100, there is a plus or minus 0.1%. Then similarly, relative error in 9.89 gram is 0.01. That is a relative error in this also, absolute error in this also, by true value 9.89 into 100%. 100% that will give the plus or minus 0.1%. Here, even though we will have the absolute error the same value in these two, but the relative error expressed in the percentage will have the different values. Then finally remember that intermediate results in multi-step computation should be calculated one more significant figure in every measurement than the number of digits in the least precise measurement. The least precise measurement, the what the value should be taken, more than that one significant figure should be taken in the intermediate steps of the calculation in the multi-step computation, and in the final result that is rounded to the proper significant figure. This will further continues discussion with taking the one example. The data should justify these, and then arithmetic operation may be carried out. If the data is justify this, then the arithmetic operation can be carried out. Otherwise, rounding errors can build up. The rounding error can build up. How that rounding error can build up if you not consider this the by the one more that is significant figure in the minimum precise value of the significant figures. How that will be there? We take the one example. For example, reciprocal of 9.58 calculated after rounding off uh, to the same number of significant figures, that is a 3, is 0.104. Here the three significant figures are there. Here also three significant figures. If you take reciprocal of 9.58, we are going to get 0.104. But the reciprocal of 0.104 calculated to the three significant figures is 9.62. Here we can observe that 9.58 reciprocal is 0.104, but the 0.104 reciprocal is 9.62. This is the rounding error. This is the rounding error which will be differ from the original value. How that can be eliminated? How that can be overcome? However, if we had written 1 by 9.58 is equal to 0.1044, then the reciprocal of this that is rounded to the three significant figure. Reciprocal of this will take whatever the value will get, that will be rounded to the three significant figures. Then we will have retrieved the original value 9.58. From this we will come to know that keeping the one more significant figures in the intermediate steps of the calculation will lead to the better precise value of the calculation. Then this example justifies the idea to retain one more extra digit than the number of digits in the least precise measurement in the intermediate steps of the complex multi-step calculations in order to avoid additional errors in the process. The additional error may occur in the process. To avoid that one, this can be followed. This is about the uncertainty and error in measurement. Both are same. The uncertainty or error occurs in the measurement and the further calculations of those measured values. And if you follow these values, and we can minimize the error what those can build up during the calculation of the some values. The next part of this units and measurement chapter I am going to take in the further sessions. Thanks for watching. If you like, share, subscribe and comment.